Okay, so welcome to the Data Modeling Showdown, unraveling the mysteries of different data modeling approaches. So I'm East. I'm the head of analytics at Advancing Analytics. I originally started my career as an analyst before becoming a BI consultant and progressing from there. I do have an unusual name, and many people get it wrong, and that's okay. If you just remember the compass direction, you'll always get it right. I'm originally from the southwest of England, spent over a decade in London, and now I'm living in France, just outside of Paris. And I love talking about analytics, sharing ideas, and helping everyone get better at it. The pace of change in technology often feels like everything is happening everywhere all at once. And as a result, data modeling has fallen out of favor, largely because the technology used in the early days of big data didn't really support it, and it got forgotten about. Before, and then everyone was reminded of data modeling with the advent of data mesh and the concepts of data as a product. The reality is technology changes all the time, but some things remain eternal. One of those eternal things is data modeling. A lake house is a warehouse on a different technology. The patterns and principles are the same. How you do it is actually just going to be very different. But the principles and guiding themes are always going to help you. I've always found modeling to be important, and if done well, help solve a lot of problems that businesses encounter. So, what is a data model? Ultimately, it's a blueprint for a system. It can be used for operational systems as well as analytical systems. So, in your careers, you might have worked with operational systems with a terrible data model or an apparently non-existent one. And that has then impacted what you can do with the data. So the importance of a data model very early on, whether that's in an operational system or an analytical system, is very key. The data model itself should represent the business processes, and to help articulate those processes, articulate those values, they should be described in nouns and verbs, and that applies for any type of data model. So nouns and verbs. So the business processes and events inside a data model can and should always be described using nouns and verbs, with each noun having a series of adjectives to distinguish itself from other nouns. We can use basic grammar to describe a model so that it can be easily understood by a wide audience. For example, a customer buys a product, an employee orders stock, or a company manufactures a product. Technical terms, which we all use in our own everyday parlance, things like entities, facts, dimensions, links, and hubs, often cause a lot of confusion, particularly with people who are unfamiliar with our own technical language, and that some people will also have a different understanding about what those concepts mean. I've been asked a few times, particularly when it comes to defining a data model. Is it a warehouse? Is it a data mart? Is it a fact table? Is it the semantic model? Is it a report? And the answer is yes. It is all those and none of those. So let's use a very tenuous analogy. Let's imagine that we're designing an apartment building. The overall building itself has a design, and that will encompass the overall structure and goal of what a data model needs to achieve. And within that apartment building will be individual apartments, and each individual unit has its own design. They might be very formulaic, they might be unique and tailored depending on the principles that are being applied to this building. And each apartment unit and building will have shared facilities to make things all work. So we can think of these things like our date dimensions, our time dimensions, things which are common across the different units. But when you bring all the units and the shared facilities together, we have our apartment building, we have our complex. So the different levels of a model, they are all one and the same, yet very different at the same time. So that might have cleared things up. It might not have, but that's a tenuous analogy. So we have 4 perspectives that we need to consider within our model: our user, our conceptual, our logical, and our physical. So our user model is probably the most familiar and widely recognized format. It is a tabular structure, a table format. It's used in a variety of databases and desktop software products like Excel. It is a highly accessible format, so it can be used by accountants in payroll through to HR managers within human resources. The weakness of this format really comes from its readability and its application to encouraging quick decision making, in that you get a lot of detail, but it's not very readable. If we enhance it, we can include some graphical representation of the data to produce readability, which is ultimately missing in tabular formats. A physical model, which hopefully a lot of you are familiar with, it is ultimately a technical tool used to underpin a data model. In this example, we're using a dimensional model within a warehouse, and the physical model defines how that database, that structure, is actually built. It will document things like relationships, keys, and data types. As such, a physical model is a tool for data professionals and developers rather than general users. A logical model is a middle ground between a user model and a physical one. It starts thinking about entities in a business event and how to link them without getting overly concerned on the technical detail of how these things connect. But before we get to that logical or physical model, we need to come up with a conceptual data model that is used to define business terminology, processes, and rules. But why do we do conceptual modeling? Ultimately, it's so that everyone can agree on the definitions of concepts. Concepts like customer or product or train. What is a train? Is it made up of rolling stock, carriages, and an engine? Or is that an asset? Is it the 1209 from Gare du Nord to St. Pancras? Or is that itself a scheduled item? Is it today's 1209 from Gare du Nord to St. Pancras? Or is it plainly just a marketing concept, for example, the Orient Express? And conceptual modeling will help everyone agree and align with this definition of a concept, because everyone will have different interpretations of what it means. As we've seen, there are 4 definitions for what a train is. And by doing conceptual modeling, we're able to hone in on what everyone thinks it should be and what it really means to the business. So the showdown itself. Hope you're all fans of Westerns, because if not, this analogy is going to be wasted. But we're going to have a showdown. We're going to introduce our characters. Our characters are going to be the forms of modeling approaches within an analytical area. And at the end, there will be one model standing. So introducing our characters. First up, we have Data Vault. So Data Vault is a data modeling approach that is used to use the lingo, building scalable and adaptable data warehouses. So it consists of 3 different types of tables: hubs, links, and satellites. So hubs contain business keys, links define relationships between the hubs, and satellite tables can store historical data changes. So the reason why it's defined as a scalable and adaptable data warehouse is that it's really very normalized in its structure, in that there are very well-defined patterns that can be applied across a variety of industries. And by keeping the definitions of the concepts and quite well defined, and the structure of the tables also quite narrow, you're able to simplify an integration process from multiple sources. With the satellite tables, you're able to support incremental data loading quite easily, and it provides a very flexible foundation for evolving business requirements in data analytics. And that's because the business logic which is applied to other forms of data modeling is kept separate from the data model itself. So next up, we have graph. So graph is a data structure consisting of nodes and edges, and those edges represent relationships between nodes. Nodes can represent entities or objects, and as I said, edges represent the connections or interactions between those different types of entities. Graphs are more commonly used for complex relationships. So if we're thinking about things like social networks, recommendation engines, network flows, or even things like supply chain, graph is best suited to detailing those complex relationships and how each element interacts with each one. Dimensional. This is the most commonly used form of modeling within a data warehouse and business intelligence environments. It consists of a central fact table surrounded by multiple dimensions, all connected to a fact table via foreign keys. There are two very similar types of dimensional model, the star and snowflake schemas. The star simplifies analysis by denormalizing data and reducing the number of joins required, resulting in faster query performance and easier report generation. Whereas Snowflake itself is more, you can treat it more conceptually as an extension of the star schema, where dimension tables are further normalized into sub-dimension tables. Benefits of a Snowflake schema over a star schema is that it reduces data redundancy, improves data integrity, but on the flip side may require more complex query structures because we're introducing more complexity into the overall design and structure of the model. There are nuances to how star schema and Snowflake schema have evolved in their philosophy, but we'll come on to that a bit later. So next up, we have entity-centric. So this focuses on wide, rich tables anchored on entities. So providing a comprehensive view of a single entity. So things like a customer or a product will have everything related to that single entity on that table. So it simplifies analysis in that all the metrics, all the hierarchies, all the things you want to analyze a single entity by are on that entity, and that minimizes the need for joins. It applies a feature mindset, which we might more commonly encounter in data science, to the forefront, which then allows for more effective use of techniques like segmentation and classification. Last up, we have one big table. This guy is mean. But the one big table is also known as a flat or denormalized data model. It's an alternative approach to data organization where everything is just stored on one table. It simplifies data access and query performance because you've only got one query to optimize for, especially for analytics that involve aggregations or full table scans. But alternatively, it does lack the structural benefits and flexibility of more normalized models in certain scenarios. So if we're thinking about our business as a whole, all our business is just going to be sitting on one big table, or it might be split out into a few big tables, depending on the types of analysis you want to apply. But ultimately, it's going to be optimized for any given query. So when would we consider using a modeling approach? If you want to consider change tracking, we've got sections of dimensional, data vaults, graph. If we're looking for how we handle complex relationships, we've got data vault and graph. If we're looking for perhaps consistency, we can explore dimensional and data vaults. And if we're looking for things like geospatial analysis, we can use something like dimensional or graph. So looking at this table, dimensional modeling really does satisfy most of our use cases. So that makes the dimensional model the victor, right? Well, not quite. The dimensional model is the most flexible one, but it's not best suited to do everything. It's not a one size fits all. This will be the panacea to your problems. It is a tool to be used within your arsenal. Joe Rees calls this mixed model art. So use modeling for the use cases that you have. So for most use cases, data modeling, the star schema in particular, is going to be applicable to what you need it to do. For regulated industries where you need to track history and detailed lineage of each record, you can use data vaults to conform your data from disparate systems and then use that to feed into a star schema for analytics. It's also possible to implement one big table or entity-centric model from a star schema, whether that's because the end user demands it that way, or maybe it's needed for the next reporting tool or the next analysis layer. What all these different types of models display are various forms of specificity. So if we have a use case that needs a high level of specificity, we can use vaults. If we need a single generic output, we can use one big table. And if we need something in between, we can use something in between. There's no single right way. I'm always going to be a strong advocate for dimensional modeling because it does fit most use cases. But if the use case doesn't require dimensional modeling or dimensional modeling doesn't support the use case, don't use it. So if we're to look at how we might want to practically apply mixed model arts, we have our tables incoming from sources. That's going to be a gigantic jumble of unstructured, structured and unstructured data. It could be coming from everywhere and anywhere. And then we can conform it into our data vault. And from data vault, we can then conform it into what we require for most analytical needs in our dimensional model. And then for our niche modeling areas, we can then transform that into our one big table or into our entity-centric model. So a lot of data models fail because they focus way too much on technical implementation rather than providing business value and meeting business requirements. So where things like Star Schema and Snowflake differ is really from the ideological and philosophical backgrounds of their discoveries. So Ralph Kimball, who introduced the world to Star Schema, was very much go and talk to people, find out what their requirements are, and build the model to their needs. Whereas Bill Inman, the discoverer of Snowflake, was like, you've got the data, build out data model to suit the data and make sure that that fits requirements. So you've got two different approaches, and where the most effective data models come into being is by being collaborative with the different users that exist in your organization. Ultimately, analytics is a collaborative exercise, and data modeling bridges that gap between technical and business users. By agile, we mean that it delivers incremental iterative value. A design that you start off with is not necessarily the one that gets implemented, as organizations, strategies, and requirements will always change. What was suitable perhaps 5 years ago is no longer relevant. And then you'll always have people hold on to the models that they perhaps designed 10 years ago and say, this is how we operate as a business. And the reality is that 10 years is a long, long time, not just in technology, but also in life, in any business. The change that most organizations go through, that have gone through 3 different types of operating models within those 10 years. So data models are not static objects. They are continuously evolving to support the needs of an organization, and we need to design them in an agile manner that is collaborative with users. So how do we do that? So we could use a technique called BEAM. So BEAM stands for Business Event Analysis and Modeling. As in this book, Agile Data Warehouse Design by Lawrence Core, that underpins the BEAM approach. Ultimately, it's a process that captures the core elements of a business event to ensure that the correct measurement and values are captured. At its core comprises the 3 Ds and the 7 Ws, which we'll go into next. So the 3 Ds relate to discover an event, describe the event using nouns, verbs, and adjectives, and then document the event in a conceptual model. The 7 Ws are tenuous Ws. There's 5 Ws and 2 Hs. So the who. The who within a given process is often going to be an individual or an organization. So it could be the customer, it could be clients. It's the actors from within the business or suppliers who provide goods and services. The what is generally aimed at the topic of an event. Could be products, could be services. The where could be where the goods were sold, where the goods are stored, where they get distributed from, where an order is being sent to. When is really when it happened. When did the event happen? There might be occasions where this question might need repeating more than once, because there might be occasions where many whens happen. When an order was made, when the order was dispatched, when the order was received. Why is not always an obvious one to answer. In a sales situation, the why may be because there was a promotion, or perhaps external factors such as a weather warning driving up the sales of snow shovels. How is another question that can be challenging, because there may not be always, it might not always fit an event. An example of a how might be a sales transaction that may refer to the journey within your commercial activity, but it may not be. And then the how many is how we define our facts, where we establish any quantitative values we'd like to capture in a given event. For example, the number of orders, the profit margin, or sales quantities. And all these 7 Ws, all these questions that we're asking of users, of the data, of the process, are designed to encourage stakeholders to think about their business events and processes in a dimensional manner, even if they aren't necessarily familiar with dimensional modeling. An alternative is sun modeling. So sun modeling is probably going to be new to lots of people. Many people might have heard of Beam, but sun modeling is much more niche in its exposure. It is a word of mouth technique developed and taught by Mark Whitehorn, who's the professor of analytics at the University of Dundee. At the heart of our sun model, we start with our quantitative measures, which apply to a business process or event. Give an example of a sales transaction process. We might want to see the profit margin, the unit quantity, and the unit cost. From that central circle that we have, we draw lines out to the different objects. So we want to slice and dice and group our central values by. So one such object could be a given date. To answer the question, when did an event happen? You might also want to group by customer to determine spending patterns, or by product to see which lines are selling best. Those objects are going to be our dimensions in a dimensional model. On the lines out to our dimensions, we then create branches to cover some of the attributes we may wish to see. So for a product, it might be brand or color. For a customer, it might be their name or age. Or for a date, we might want to know the month or week or even quarter. Another core concept here is that we can represent hierarchies using a single straight line from the center to the dimension to indicate the hierarchy starting at the lowest grade and working up. So for example, within our date, we've got day, month, quarter, and year. Another rule with dimensions in sun models is that all measures at the center must be sliceable by each dimension. And if that can't be achieved, then a new model is needed. Another alternative is Sunbeam. So Sunbeam has been developed by Advanced Analytics, mostly proposed and espoused by Johnny Winter, who's doing this a little bit this morning. But Sunbeam is a bit more than just a data modeling technique. It's a analytics product design framework which enables you to discover where your analytics implementation can bring the most value to your business quickly. So we mentioned that analytics is a collaborative approach. It's also an iterative discipline as well. And Sunbeam aims to harness the domain knowledge that exists within the business, and they will typically represent themselves as subject matter experts. And by using Sunbeam, we're bringing them along the journey of our analytics design and implementation, whilst we're also empowering data teams within organizations to transcend their traditional roles and become trusted partners for their business counterparts. But it starts at the very top with the overall strategy of an organization and distills it into a distinct unit of value by way of process and event identification and prioritization. And it is also an iterative process. So once we've identified that value point, we've then delivered that value point, we're then going out and searching for more value points. And it's always going to be an ongoing process. So it is much more than a data modeling technique, but the data modeling technique it introduces is valuable by itself. That's what we're going to go into next. So Sunbeam, from a modeling perspective, combines the two previously discussed methods of Beam and Sun modeling, and it takes the best parts of each approach to form a single method to capture and present the valuable intelligence from a business process and output that into a universally understood model. But If we're starting with an event, how do we identify an event within a process? We start with a timeline. So what is the most important event that happens in a given process? For example, the sales process. It could be customer buys product, but what happens before that event? Well, a customer browses a product. We know this because we've logged their activity on our e-commerce website, or we've tracked them around the physical store. Cool. What happens after? A customer leaves a review. Okay. What happens if they give a bad review? Well, a customer returns a product, and these are the different events that happens within our sales process. And this is simplified, but we can start drawing this out, start adding more events that might be identified, but also don't force it. If there isn't any more events, that's fine. Just move on to actually modeling that event itself. So our event is always going to be defined by who does what. So customer buys a product. But like some modeling, our initial focus is going to be on the how many. As we're drawing this out, we're documenting our conceptual model in real time with our audience, so they can verify and check and make sense of what we're conveying and what they're telling us and agreeing on the concepts in which we're discussing. So our how many, so numbers of orders, our profit margin, our sales quantity. The who, we want to flesh out who our who is our customer, what is our customer, what did they buy, what is a product, and there will be many definitions of what the who is and what the what is, but by aligning the concepts through by asking what does a customer look like, describe a customer to me, describe a product to me. A lot of people start describing the same thing, but they might have different names for it. So our who could be a customer in one department. It could be a client in another. Our product could be a product for marketing teams. It could also be an asset within finance. But when we're describing these things, people will start realizing that it is the same thing they're talking about, and then it's a matter of semantics as to what we actually call it. The where, again, you might have different terminologies for the same things. You might have location as a very generic bit. So that location could be a store. It could be a bin in a stock in a warehouse to keep stock in. The when is probably going to be less contentious. However, there will always be times where dates mean more to some people than others. The why, the how, and then our eighth W is how often. And the how often is the cadence of that business event. It's how often does it happen, and that how often is that event captured and recorded. And that's not really that important to the modeling aspect itself, but if you are thinking about how you're going to orchestrate your event from source to target, that how often matters a lot, because that is going to ascribe how you need to interrogate those sources and how often you need to refresh your target. Tips to use with Sunbeam and also with Beam as well is to ask the W's multiple times. Often there is going to be more than one answer, although you should really only get one answer with how often. For some W's, there may be no answer. Always produce one Sun model per event. Don't get bogged down in what you already know about the data. Try and keep it as free of data as possible. But saying that, it isn't a finished or fixed design. It is a target, and this design may change during implementation, particularly when we start thinking about what the data actually is and how that interacts with and shapes our conceptual model. The conceptual model is there to convey complex ideas. It's not there to be, this is the target, because the target itself is going to be described in the logical and physical models. And we need to make sure that our conceptual, our logical, and our physical all align, not from the detail perspective, but from the concepts in which they convey and how they're going to be doing it. So if we think about our building analogy, our conceptual model is going to be our architect's sketch. It's going to be the nice image that you see in marketing materials. Our logical model is going to be the architect's blueprints, where there'll be some detail, but not all the detail. And then our physical model is going to be the builder's blueprints, the stuff that will get signed off by quality control, building control, and will have the little measurements to know that this radiator needs to go in this location, otherwise you're not going to be able to open the door, and things like that. So as a refresher, the 3Ds are to discover an event. So who does what? Describe the event using nouns, verbs, and adjectives using the 8 Ws, and document the event in a conceptual model using sun modeling. Other things that we can use to help us is to reduce, reuse, and recycle. So 50% of a data model will follow generic patterns. So any authority on modeling, such as Kimball, will have written about generic patterns, such as currency conversion, how to handle ragged hierarchies, even how to generally apply history tracking in slowly changing dimensions. If you've worked with many businesses in the same industry or across similar industries, you'll notice very similar behavior and processes. For example, if you've worked with finance teams, the requirements for general ledgers are going to be very similar. And there's always going to be an opportunity to reuse patterns. But what makes an organization unique are the things that deviate from the norm or need to accommodate the quirks of the organization itself. Every company is a data company that just happens to do something that differentiates itself from other data companies. So there'll always be an element of uniqueness to an organization. So we can reduce overall effort by reusing the effort of other people like Kimball, and we can recycle patterns that we've come across before. So if you want to get your brain juices flowing, there are a couple of books to read. So the first one is the Agile Data Warehouse Design by Lawrence Core. That lays out Beam, but you also want to read an old one but a good one, and that's the Data Warehouse Toolkit by Kimball. The Nimble Elephant is very much geared towards operational systems, but is also very invaluable in terms of just knowing that the design of a operational system is very similar to that of an analytical one. It all starts with the business process. There are some elements of reusability, and it's all about making sure that everyone is conforming to the definitions and concepts in which they need to agree on. If you're interested in learning more about Data Vault, there is Building a Scalable Data Warehouse. with data vaults by the discoverers of data vault. And from a modeling perspective for Sunbeam, my colleague Shannon has written an introductory blog on the AA websites. So thank you very much for listening. I hope it has been insightful.